Registers. A register consists of a group of binary storage cells. A register consists of one or more flip-flops depending on the number of bits to be stored in a word. A register is a binary function which holds the binary information in digital form. Shift register. A register that is capable of shifting data one bit at a time is called a shift register. Serial shift register consists of a chain of flip-flops connected in cascade. The output of one flip-flop being connected to the input of its neighbor. The operation of the shift register is synchronous. Thus, each flip-flop is connected to a common clock. Using D flip-flops forms the simplest type of shift registers. Types of shift register. Basic shift registers are classified by structure according to the following types: serial in, serial out; parallel in, serial out; serial in, parallel out; universal parallel in, parallel out; ring counter; serial in, serial out. Above, we show a block diagram of a serial in, serial out shift register which is 4 stages long. Data at the input will be delayed by 4 clock periods from the input to the output of the shift register. Design issue. Data at data in above will be present at the stage A output after the first clock pulse. After the second pulse, stage A data is transferred to stage B output and data in is transferred to stage A output. After the third clock, stage C is replaced by stage B is replaced by stage A, and stage A is replaced by data in. After the fourth clock, the data originally present at data in is at stage D output. The first in data is first out as it is shifted from data in to data out. Parallel in, serial out. Design issue. Data is loaded into all stages at once of a parallel in, serial out shift register. The data is then shifted out via data out by clock pulses. Since a 4-stage shift register is shown above, 4 clock pulses are required to shift out all of the data. If 4 switches were connected to DA through DD, the status could be read into a microprocessor using only one data pin and a clock pin. Since adding more switches would require no additional pins, this approach looks attractive for many inputs. Serial in, parallel out. Design issue. After the first clock, the data at data in appears at QA. After the second clock, the old QA data appears at QB. QA receives next data from data in. After the third clock, QB data is at QC. After the fourth clock, QC data is at QD. This stage contains the data first present at data in. The shift register should now contain 4 data bits. Parallel in, parallel out. A parallel in, parallel out shift register combines the function of the parallel in, serial out shift register with the function of the serial in, parallel out shift register. So, it is called as universal parallel in, parallel out. Design issue. Data presented at DA through DD is parallel loaded into the registers. This data at QA through QD may be shifted by the number of pulses presented at the clock input. Ring counter. If the serial output of a shift register is connected to the serial input, data can be perpetually shifted around the ring as long as clock pulses are present. If the output is inverted before being fed back as shown above, we do not have to worry about loading the initial data into the ring counter.